Hello, welcome back to Getting Started with Generative AI Research. So far we discussed pretty straightforward application of large language models when you were just directly asking LLM to do something. For example, please generate me an idea, please classify this text, annotate this text, please help me to write a code to analyze my data. And now we will be moving to more complicated, but also more interesting, but also maybe a bit less valid applications. Less valid in the sense that we cannot probably rely on them entirely to do research, so it's kind of experimental. They're at experimental stage, that's why I call them emerging applications. But I think they should be interesting, so I hope you will enjoy this couple of examples that I have. So the first idea is what some people call creating silicon samples. And the idea here was, okay, maybe once we have these LLMs that seems to be, quite naturally speaking, maybe we can use them as sort of like silicon samples. Maybe we can interview LLMs and maybe this would reproduce results from, surveys that was done with normal humans. There was this interesting paper that was written by political scientists. So that's why it's like in a political context. And so the idea was, let's maybe create a, profile for LLM. Let's say, that ideologically, we will tell LLMs that it should think that it's conservative, that it is strong Republican, that it's white, male, from upper class, young, etc. And then after we provided this kind of profile, this role to this LLM, let's ask it, what does it think about Democratic Party? And then it probably say something like, they're all liberal, they're also like socialist, communist, and atheist, or something like that. But if you ask like Democrats, then probably Democrats wouldn't describe themselves as communists. They probably will say that, we are like maybe liberal, young, female. Similarly, if you ask Republicans to describe Republicans, they might say that they're like conservative, male, white, or Christian, but they wouldn't probably call themselves homophobic or racist or ignorant, while Democrats might describe Republicans in this way. So the idea was just to ask people how they would react to these prompts and also ask LLMs and just to see if the results from humans can be reproduced by LLMs. So this is not the easiest plot to read, but what is happening is that here's a list of words, and these words are often used to describe Democrats, like liberal, people, young, progressive, etc. And these are words that are used to describe Republicans, like conservative, white, religious, etc. So now, what we can also see is like how often these words would be actually used when describing Democrats or when describing Republicans, and also by whom. So this would be extremely conservative, this would be independent, and that would be extremely liberal. So, and for example, for all these leanings, the results would be consistent in the sense that all humans would be thinking that Democrats are liberal, and much lower amount of people would say that Republicans are liberal. And the same, conservative is a term that's used to describe Republicans, and it's not used to describe Democrats. I think the most interesting of these plots is something when we can see correlation with this political leaning. For example, you can see that, if you look at the educated, so you can see that if you are conservatively lenient, you would say that Republicans are educated. But if you are liberally, extremely liberal, then you would not say that they're intelligent. And in fact, extreme left would call Republicans probably stupid, not intelligent. And I think there's a similar result here, for example. For example, if you are left-leaning, you would say that Democrats are caring. But if you're conservative, you wouldn't consider them caring. You also wouldn't consider them intelligent. So I think these are the most interesting rows here. And so for now, we're discussing this human part, but there's also GPT-3 part. When GPT model was asked the same, and they were creating these different profiles when it was like independent or extremely liberal, extremely conservative. And they say also that it's generally kind of reproduce results in some sense. So you can see that, for example, as the model would also describe Democrats but not Republicans as liberal, and GPT would also describe Republicans as conservative but not Democrats. But this kind of nuances, like about educated or intelligent, doesn't seem to be like reflected. So it was kind of promising but not really exactly reproducing everything. Where authors get like a much better results is in trying to predict voting preferences. So they were creating different profiles, like they were asking LLM to imagine that it is like white or black or Hispanic, if it's conservative, etc., and then trying to predict what would be its preference in voting. And you also know like real data, so you know for different socio-demographic groups how they vote. Is they vote Republican or Democrats? And there was some sanity check results. For example, if you ask model to imagine the strong partisan, it should vote for corresponding party, and this was reproduced. And generally, they say that they have a pretty good agreement between the LLM experiments and actual voting patterns, and this was reproduced for a couple of years. So this paper was very famous in my community, for example, I guess because it was one of the first that had this idea of using silicon samples. So this idea was floating. I know like many groups were doing something like that, but this paper was published early, and it was received a lot of attention. There's also a lot of criticism of this, and the main criticism that I also agree with is that it seems like when they frame it like that you use large language models to simulate human samples, you can almost imagine that you're creating this profile, and then the model somehow understands preferences of this person with this profile, and it can guess how this person would be voting. So it kind of trying to create this idea that it can be actually used for modeling. But if you think about it, what it actually does, it just knows some preferences. So we kind of know that women are more often vote for Democrats. It's just a simple fact. And in this training data that was used for LLMs, it was repeated many times because that's something that is very well known. It's something that's discussed in media. So the model just knows that women vote Democrats. And this is, if you frame it like this, it is much more trivial fact, right? So if you think about it, okay, that's not actually, creating silicon samples and modeling human behavior. It's just reproducing a well-known fact. And in fact, there were some follow-up studies, for example, when people try to apply it to European settings, where everything is much more complicated because you have more parties. You also have new parties, and then like a new party appear, and you have no data on it. Can the models actually predict what would happen? And it turns out that this results from this paper was not reproduced at all. So there was like nothing. So we have to be skeptical about these results, and I'm very skeptical about this particular paper, but I think the overall idea is interesting and maybe worth exploring. So now let's move to another example. So in this example, in the previous example, what we were doing, we were trying to kind of simulate a person who is interviewed or who is surveyed. And in the next paper, what authors were trying to do is they're trying to simulate an interviewer, not the person who is interviewed. So why we use interviews and not surveys? Because probably we can get like richer data from interviews. But the problem with interviews is that they're time consuming, right? So it's very expensive to conduct interviews. That's why in many cases we just prefer surveys. But what if we can automate them? What it can be not a human but a LLM who is conducting interviews? Then we can do it like almost on the same scale as surveys. That would be like very easy for us, very cheap. We just run this chatbot, and it will conduct interviews. So that was what the authors of this paper were trying to do, to see if chatbot can conduct an interview. And here's an example of this interview. And this shows also like why using large language models might be a good idea, because you kind of can automate asking questions, right? There's nothing complicated about a computer asking you one question and then another question and then another question. But that would not reproduce, what interviewer would do. For example, some interviewers, well, it depends on the type of interview, but some interviewers might want, to kind of connect to what you were mentioning before, just to show that they're listening to you. And in this example, for example, you see that the person is asked about what's good about democracy in Western countries. And a respondent is answering that, it's less corrupt than other countries, like recent election in Russia. And then this AI interviewing is, saying again, repeating just what the person said, that, you think that the systems are there less corrupt. And that's create like a much more real connection between this interviewer, even if it's AI, and maybe it could lead to better results. So this was like a very small sample size in this study. So I wouldn't say that there is some, interesting conclusions we can make. But I think what we can see is that there was not much difference between AI interviewer and human interviewer. And so at least, it's hard to say what is better, but it could be, you could imagine that, AI interview would completely fail. And like everyone would be saying that everything is very bad. So here you can see responses of humans and how these responses were, if they were clear, if they were engaged, etc., grammatically correct. And you can see that there was not much difference, more or less the same. So it seems that the responses are not suffering from this type of interview. And also when humans were asked to evaluate how good these models were, they also say, more or less the same about human interviewers and AI interviewers. Like, I don't know, you see this two dots here for AI interviewer, but also like one for human. So this on average seems to be kind of better, but how much better is very hard to deduct from such small sample. So I would say the main conclusions that we can make is that AI interviewer didn't fail, and that's already kind of cool and interesting, and we probably can build on top of that. So let's move to another example, and now it will be about agent-based simulations. So the idea here is a bit more complicated than in previous examples. So the authors of this paper, what they did first, they create kind of artificial environment that was kind of small town or village. And this village contains some, parks, some houses where people can live, some like cafes, some community spaces, pharmacy, etc. So after they created this environment, they populated it with agents. So they created these personas, and they created a backstory for these personas. And this backstory was just written in natural language. And the idea was, because now we have access to large language models, we can actually, just describe desired model behavior or backstory just using natural language. And that's the main advantage that large language models are bringing to us. So, for example, this person was called John Lin. So, and you can see that he's working in pharmacy. Then the authors also describe some relationship. For example, there's another person, Sam Moore, and John Lin thinks that Sam Moore is kind and nice man. John Lin also knows some people, but not everyone else. So there's some background of this person. And after they created a couple of these persons, they just let them kind of navigate in this environment they created and just talk to each other. And that's why large language models are so cool, because they didn't need to program any of these, talks. They just automatically generated by GenAI model, and they're discussing with each other, like, I don't know, this person is asking about upcoming mayoral election, and this person say, I don't really know much, etc., etc. So I think at this point it looks like just a strange game when you are not even playing. But the idea was that you can actually try to run some experiments in this environment. Before that, maybe I have to mention that it is not like exactly just using just a basic LLM model. They have to create a more complicated system. So they wanted these agents to have some memory, and this memory was retrieved. And after this memory was retrieved, then it was provided as a context to large language models. And large language models was saying, okay, given these memories, I would, say this thing, or I would act in this way. So it was a bit more complicated algorithm, but it was mostly powered by large language models. So what type of experiments can we conduct? So, for example, you can study maybe information spread. And so what authors of the paper try to do, they selected a person and they say that this person is planning to do a Valentine's Day. So, and how they say it, it just provides information to this particular agent. So nobody else is knowing about it. It's not encoded anywhere in the system except in the description for this person. And then they just allow model to run and just to see if this person decides to tell about this party to someone. And she actually decided to tell to 1, 2, 3, 4, 5, 6 to 7 people. I think there was in total 12 or something, maybe 20. So it tell to some people, and some of that people tell to another people, like Sam told to Jennifer. I don't know, probably they're a couple, I'm not sure. And what was also interesting that Klaus told about this to Abigail, and Abigail actually returned to Isabella back and said, I heard you playing the Valentine's Day party, etc. So, there was no guarantee that it would work, but it worked, and it seems that the person was discussing something with other people. So you maybe can use it for modeling, spread information and all sorts of other behaviors, right? So you can, one of this agent, you can give a specific task to this agent, and you can just see if this task is actually completed or not, and how it might depend on different parameters of the system, etc., etc. What is also interesting is that because it is powered by large language models, you can actually kind of analyze what's happening just by talking to these personas. So you can, for example, ask these personas to introduce themselves. You can ask them about their occupation, interests, etc. And that allows you to check, if they really understood their role, right? So if you said them, you're a pharmacy shopkeeper, and then you ask this person where you're working, and they answer you, I'm working in, I don't know, in university, it means that they kind of didn't understood their role. And you can do it, by just using natural language interviews, which give me a bit of this Westworld kind of vibes. And you also can conduct the same interviews after a simulation. So, for example, you can actually ask, did you hear about Valentine's Day party? And you can also check if it's working as expected. For example, the model, if there was no interaction between someone who knows about party and this particular agent, then this agent should reply, I never heard about it. And in this case, this person actually heard, and he or she knows that it is about Isabel Rodriguez, who is organizing this Valentine's Day party. So it's kind of cool that you can just interview them and to understand what they know, what they don't know. You can also see how their relationships are evolving. So, for example, they might have some interactions, and during these interactions, they might change an opinion of a particular person, and then you can interview them and to see what's their opinion. So now I think that's like super exciting, and that's why I have to make a warning that you should be, excited, but not too much, because it's not working perfectly. And I'm actually really glad that authors of this paper provided their own example when it failed, because I think it's just really important, and it's also like very interesting to see how exactly it failed. So, for example, one of this person was called Adam Smith, and then another agent, Eureka, was asked to describe this person. She answered that it's an economist who authored Wealth of Nations, which is not true because, this is just about another Adam Smith. And because this is powered by LLMs, and these LLMs are trained on the whole amount of data, they know a lot of things. And some of these things are probably ingrained in them very well, like that Adam Smith is so famous and he's authored Wealth of Nation. So they didn't realize that Adam Smith is their neighbor. So that kind of didn't work, this part of the solution didn't work. And another concern is that, even if you kind of reduce such problems, there is still little guarantee that how these agents behave is has any relationship with how real humans behave. The ultimate goal is probably to be able to create simulations that can help us to learn something about humans. But if it's just, completely unrelated experiences that its agent have, then it's not so useful, just kind of a funny game. So, and for now, we don't know. We don't know how well it can capture real dynamics, but I think it's like a very cool and interesting idea, and I will be trying to see how all this evolves. And the final idea that I want to discuss with you is about equipping LLMs with tools. So I think we discussed that LLMs, they kind of struggle, especially until recently, with some very basic tasks. For example, they would can struggle with very simple math. But the thing is, like, we shouldn't worry about LLMs struggling with math, because math is not some unsolvable problem. We already have calculators that are doing this math very well. So maybe instead of worrying that LLMs cannot solve mathematics, we can just provide them with access to calculator, and the problem would be solved. And this was kind of the idea of this project that was called ChemCrow. So it's kind of chemistry LLM. And there are many tasks in chemistry that would be hard for LLMs to do just because of how they work. For example, if you have a notation for a molecule, you would probably be interested in knowing what's the weight of this molecule. But this is something that LLMs probably would struggle. But there's a tool that do exactly that. So you can just, input notation. There's like a standard for chemical notation called SMILES, and it can return you molecular weight. So the authors of this tool, they just used normal GPT model. So they're asking to provide open AI API, but they also give access for this model to different tools, useful chemical tools, and then they see how well it would perform in solving chemical tasks. And actually what you can do, it can be not just, a simple calculator or returning a weight of a molecule. One of these tools can actually be, a robotic labs. So there's like now these labs that are fully automated. And they can conduct some experiments. And for that, you just need, to send them a command. So you can now give to this chemical LLM, chemistry LLM, you can now give it access to this robotic lab, and then it will be able to conduct some experiments. And I think that's opened like a whole new world of possibilities, how you can use large language models for doing science, especially in natural science. And so the authors of these tools, they were also looking how well it can perform different tasks. So this plot is not easy to read because there is this increasing difficulty, but it's split in 3 different types of tasks. So the difficulty increased from task 7 to task 13, and then again from task 2 to task 12, and then again from task 10 to task 9. And what they have found that if the task is easy, then sometimes GPT-4, just naked GPT-4 without any tools, can perform sometimes better. And the author's hypothesis is that it's because it just remember the answer, just knows the answer by heart because it wasn't training data, it was some very common question. So yeah, you can see here GPT performing better, here's performing better, but not significantly, here's performing better again. But when you move to more complicated tasks, so then GPT-4 doesn't know anymore the answer by heart, and then their model started to outperform it. So this was a promising result that showing that, yes, there is this more complicated tasks, and just base/language models might be struggling with them, but once we keep them with appropriate tool, we can see a significant improvement in performance. So that's all that I wanted to share with you today. I hope that these emerging applications were interesting and hopefully also inspiring. I see you in next videos. Bye.